right, so in this part of the lesson, we are going to be given the factored form of a quadratic function, and we're going to identify the parts of a parabola. So we are once again looking at that same piece, or those same pieces of information that are on your yellow packet, pages 1 and 2, where we go through all type of vocabulary. And we've done this before, but we're just switching the given information now. So now we're going to look at factored form and be able to look at the shape, whether it's open up or whether it's open down. We're going to be able to look at the vertex. From the vertex, determine the axis of symmetry, as well as whether that vertex is a minimum value or a maximum value based on the shape. We're also going to look at the x-intercepts if they exist, if there are 0 or 1 or 2 of those. Remember, those are also called roots or solutions or our 0 points. And then we'll be able to look at the y-intercept. And today we're going to look at all of that just by identifying it and not putting it onto the graph yet. So you'll need to grab a sheet of paper, just a regular sheet of paper, and we're going to do 2 problems together. All right, so our first problem, please write down y equals x plus 3 times x plus 1. And so if we look at that, this is given to us in what is called our factored form. So the first step of the problem from standard form to factored form has already been completed for us. And from this factored form, we are going to be able to tell 2 things very quickly, okay? First, we're going to look right out in front here, and that is where our a value would be. And if that a value is positive, then it's open up, and if its a value is negative, it is open down. So we already know that our shape is going to look like this, which we call open up. Now that also tells us that the vertex would be located here, and although we don't know that point yet, we do know that that point will be a minimum value. Now, so factored form, what it tells us, what we can look at that is we know the shape. The other thing that we can do pretty quickly is look for the x-intercepts. And if we want to know what the x-intercepts are, we let y equals 0 and we solve for 0. Solve for these x's. If you remember, this is when we solve by factoring, this is what we call the zero product property. And so we know that there is going to be a x-intercept at -3, 0, and an x-intercept at -1, 0. So from factored form, we're able to get the shape. We were able to get the x-intercepts pretty quickly. Now, there are a couple different ways we can go around or go about finding the other pieces of information here. And as you get better at this, you'll see the multiple ways. Right now, I'm going to have you take a moment, pause the video if you need to, and what I want you to do is take and multiply this factored form, and I want you to get it into standard form. So what I want to happen is for us to look at it and it be y equals ax squared plus bx plus c. So we're going back several tests now and looking at that this is a binomial 2 terms times a binomial 2 terms. And so if we're multiplying them together, we're either doing we are either doing distributive property or we're doing the box method. So you decide to multiply that. Do you want to do distributive property or do you want to do the box method? Pause the video, and when you have that completed, start it again. All right, after you multiply that together, we should end up with y equals x squared plus 4x plus 3. Now, what I can know is that very quickly, if I were to let x equals 0 and figure out what my y value is, zero squared is 0, 4 times 0 is 0, y would equal 3. And so we've talked before about that value there is our y-intercept. So we now know our y-intercept is at 0, 3. Now, our axis of symmetry, we've been practicing using a formula that the x-coordinate of the vertex is equal to the opposite of b divided by 2 times a. And so if we now know our a, our b, and our c, the opposite of b divided by 2 times a is going to give us a x-coordinate of -2 for our vertex. That now tells us we know the x-coordinate of the vertex, and we know our axis of symmetry. Now, if I want to find out what the y-coordinate is, I'm going to take and substitute that x-coordinate into our equation that's in standard form, and I'm going to say that if we look at this, this would be -2 squared plus 4 times -2 plus 3. And if we do that arithmetic, then that tells me that we're going to end up with -1. And that gives us the y-coordinate of our vertex. Okay, so looking at standard form then, standard form, we were able to do our y-intercept, and we used that for our x-intercepts also. Now, we already had our shape, but we could have used it for our shape also. So that's why we are looking at being able to make sure that we know the different forms, because if we know those different forms, we can see that the factored form gives us the shape and the x-intercepts, and that the standard form is going to be able to give us the y-intercepts, and then I apologize here, I should have wrote that it will give us the vertex, and along with the vertex, the axis of symmetry. Now, if you were seeing different ways to get these parts of a parabola different than what I just went through, that's fine. We'll start to see lots of connections as we do these in class. So either go back and rewatch this one, or if you're ready, go ahead and go to the second example. All right, so looking at this equation, and this equation is given to us in factored form. First thing I notice is that I have a negative right here, and that definitely gives me the shape and tells me that this is open down. So we know that factored form as well as standard form gives us the shape. Now the next thing that I can do is, by that shape, I don't know where the vertex is, but I know that it's going to be here, and therefore I know that this is going to be a maximum value. So once I have the shape, whether it's from factored form, or from standard form, I can determine whether it's going to be a maximum or min value. That is going to help us as we start into application problems. Next thing is that from this, I'm going to be able to look at my x-intercepts. And so I do that using that zero product property that takes our factors, sets it equal to 0, and tells us that we have an intercept at 5, 0, and an intercept at 3, 0. So once again, from factored form, I'm able to determine the shape, whether then the vertex is going to be a max or min, and then my x-intercepts. Now, the next thing I want you to do is I want you to take and multiply And remember that when we move from factored form into standard form, we do that multiplication, and you can do that multiplication either by distributive property or by the square method. Some of you from other classes and working with other teachers or students even know, since this is a binomial times a binomial, you could do FOIL method. So whatever works for you, our goal is to get it into this format. So I'm going to pause, and I want you to start the video again when you have it multiplied into standard form. All right, so when you multiply it into standard form, we should end up with y equals negative x squared plus 8x minus 15. We have three things left. We have the vertex, we have the axis of symmetry, and the y-intercept. The y-intercept is probably the easiest, because if we were to let x equal 0, this would be gone and this would be gone. And that would tell us that our y-intercept would be at the point 0, negative 15. We've done that several different times with other problems before in our yellow packet. Now, to get the vertex, this is what we've been practicing. We have an equation that says the x-coordinate of the vertex is equal to the opposite of b divided by 2a. And so we would say that's negative 8 times divided by 2 times negative 1, which would give us a 4 for the x-coordinate of the vertex. And once we do that, that tells me that the vertex here is 4, and the axis of symmetry is x equals 4. And then we know that to figure out the y-coordinate, we're just going to go back here, and we're going to put in this x that we know is the x-coordinate of the vertex, and find the y. So we're going to have y equals the opposite of 4 squared plus 8 times 4 minus 15. And so we're going to get that y then is equal to 1. Okay? And now we have identified the parts of the parabola. From the standard form, we were able to get the y-intercept, and we were able to get the vertex, and we were able to get the axis of symmetry. If we didn't already have it, we would have been able to get that the a value is negative, so we would have been able to get the shape and the max or min. That shape and max or min can be gotten from either factored form or standard form. Okay, so your assignment is, in Canvas, we have an assignment called factored form. There are 2 questions, very similar to the 2 problems we just did, but you do have to fill in all of the parts of the parabola. Okay, in Canvas, we have a follow-up to yesterday's or Tuesday's assignment, which is finding the vertex and the axis of symmetry. And then I want you to make sure that you know what is factored form and what does it help you find, and what is standard form and what does it help you find. Okay, and so we just went through that in those last 2 problems. So make sure that you are able to tell me that both factored form and standard form will give me the shape. They will both also give me, with the shape, is it a max or a min? But our big difference is that with our factored form, we are most easily able to identify the x-intercepts. In standard form, we're able to use that x equals the opposite of b over 2a to find the vertex, which then gives us the axis of symmetry. And in standard form, it is the easiest form to be able to tell the y-intercept.